Hello everyone, this is Vishnu and Tech Talk video topic for discrete mathematical structure is on inclusion exclusion formula based on reflection principle. So let's get started. So moving before moving to the thing, so let's understand what is inclusion and exclusion principles. So it is a counting technique which generalizes the familiar methods of obtaining the number of elements in the union of two finite sets. So A is a finite set and B is a finite set. So inclusion is nothing but the union operation, and exclusion is nothing but the um, intersection operation, or maybe vice versa. So um, for two finite sets A and B, the formula would be A union B, which is equals to A plus B minus of A intersection B. And for three finite sets A and B and C would be A union B union C, which is equals to A plus B plus C minus A intersection B minus B intersection C minus C intersection A plus A intersection B intersection C. So this is the this is nothing but the inclusion and exclusion principle and the formula. So moving on, sorry. So what is reflection principle? In set theory, it's a branch of mathematics. Reflection principle states that it's possible to find the sets that resembles the class of all the sets. So it is possible to find sets that resembles or that are related to the class of all the sets. So that's what it says in set theory, which is a branch in mathematics. So there are several different forms of reflection principles depending on what exactly meant by resemble. So there are different meanings for that, and the um, the procedure what we are going to see is also dependent on the meaning. So this is another scientist with another approach. So moving on, this is what how the visualization of formula, which is based on reverse principle. So as we can see there, we have a set which consists of four elements: one, two, three, and four. So how exactly it works? So since there are four elements, we can we have split it into three further sets by replacing the values. As we can see, there are one, two, and three. So there's one, there is two, and there is three. Over here, what happening is the the first um, let's call it as index first index, second index, third index, and fourth index position of the set. So at the first index, this the value which is there after that index are getting swapped, which are nothing but the mirrors. They're becoming as mirrors. So as you can see, 1 2 have turned into 2 1, and at the first index position, and 2 3 since it's 2, so at the second position 2 3 will be mirrored, and we got 3 2, and 1 and 4 are not at all disturbed. So at the third index position, 3 and 4, uh, these two are being mirrored, so we get 1 2 4 3. So in a similar fashion, with this 2 1 3 4, without getting this 1 2 3 4, we can further go with interchanging uh, the I mean, since we have already used one, if we use one again, we would get the same value. So to prevent that, we will be going with the two and three possible uh, there are two possibilities, so 2 and 3, because if we swap them, we don't get any errors or something which is the starting. Let's call this as root, this, the first thing as root, and this thing, this as these all as nodes. So when we are talking like that, so 2 and 3, only these places will get exchanged so that it won't be similar to root node. So we swap let the second index, which is nothing but 1, and second index and the right side right element was 3, so 1 and 3 got swapped, so it's 2 3 1 4, and 2 1 3 4 going with 3, it's third index 3 4, so swap, so 4 3, we got 2 1 4 3 and 2 3 1 4, which are not at all similar to 1 2 3 4. We are talking about sequence, not the elements which are present in the set. So just talking about the sequence in which they are being arranged, 1 2 3 4. This is not 1 2 3 4, this is neither not 1 2 3 4. So that's how we achieved it. So since we already use 2, we cannot use 2 over here, because if it use 2, it would be similar to root node. So 1 and 3, we are going to use 1 and 3, so one place, so we are going to swap 1 and 3 over here. We get 3 1 2 4, and since we use 2, we won't use that, and getting into third index position, we got 2 and 4, and we will mirror them, and we got 1 3 4 2. Here 2 4 are being mirrored, so 3 4 2. So 1 2 4 3 over here, 1 2 4 3. Now since 3 is used, 1 and 2 are going, what are we going, that is what we are going to use. And since uh, 2143 is similar to this 2143, we are just mapping to this already existing node, but not by not creating another node. So the other possibility is 2, so we got 1423, the second index 2 and 4 are being swapped, so 1423. So in a similar fashion, 2314, since 2 is used, we'll go with 1 3. Since 3 is used, we'll go with 1 and 2. I think only we are going with 2 over here, not with 1. Okay, let's understand why not 1. If we go with 1, it would be 1 2 4 3. Since that 1 2 4 3 already exists, we won't go with that. Okay, so we will neglect, or we won't use those indexes when they would result in the already existing node. So 2143, if we use 1, it will become 1243, which will result in this. So there is only 2 over here, and over 3124 with 2. Again, there's no 1 and 3, 2 over here, and 3. Okay, 2 and 3 both are there for this node, which will not be similar to any of the nodes which are above this node. Okay, about this node, there should not be any element which will be this element. So 3142, there's no 3142 above 3124. You getting it? 3142 should not present on top of 3124. Any of the nodes should not be there, and that's how we haven't got 211 over here, 2134, or 2 or 3, which would result in the same thing. So here also same, we got 1 2 and 3 1, since we use 2 over here, and 1 2 since we have used 3 over here. And since by using these 1 and 2, these elements are not similar to any of the existing elements, so these elements are nodes, since we are talking nodes, since this node is not at all similar to any of the nodes present above, so we can consider that node or create that node. Let's call it the parent node, and this is the child node, which would be easy. So above parent node, there should not be any node which is similar to this child node. So same over here, this parent node can go with 3 and 1, 1 4 3 2, and 4 2 1 3, and these two and this or two, or let's go with one by one. And this child node is not present above the parent node. This child node is not present above the parent node. Above the parent node is this region, not this, but this. Maybe we can also consider this as well. So moving on, there's only one operation in this three. With three, we can achieve this number, which is this with this parent node going third index swap operation or mirroring it. We get this one, which is not at all there and about the parent node. So in similar fashion, each and every node is being created, and these nodes are started to decrease number of nodes that are being created, and finally they started to mirror the whole node. And this is a way to mirror the nodes, I mean mirror a set of images with the help of this method. So now 1 2 3 4 is now 4 3 2 1. Hence we can say that this set has been mirrored. I mean this set is equals to the mirror. This set is equals to the mirror of this set, or this set is equals to the mirror of this set, vice versa. Whatever we can say it either way. So this is how this principle works, and yeah, thank you.